Hello everyone and welcome to this session on DataStage interview questions and answers. Now this has been one of the most requested videos, and so I have put together a list of DataStage interview questions and their answers, and this is going to be the first video in the series of videos planned, and we'll be covering the questions topic by topic. Now to start with, the very first question that the interviewer would like to ask you would be to test your conceptual knowledge of DataStage. So this is one of the most important features of DataStage, and that is parallelism. So every interviewer would like the candidate to have a good understanding of this feature of DataStage. So the questions that they would be asking you would be, what are the different types of parallelism in DataStage? Now many times, because we are working and we are developing DataStage jobs, we think that there's only one kind of parallelism in DataStage, and that is partitioning. But there's one more type of parallelism in DataStage, which is the pipeline parallelism. So you have to understand what is pipeline parallelism. Pipeline parallelism is nothing but it is basically that as soon as your first stage in your job processes the records and starts producing some records in the output, the next stage would start consuming those records as its input, performing its calculations and transformations, and starts outputting those records. So basically the whole time taken for your DataStage job gets reduced. So the next stage does not need to wait for the previous stage to finish completely for it to start processing the records. If the stages would have worked only one by one, so if let's say the first stage would have processed the records when all the, let's say there are 100 records, all the 100 records have been processed, then only the next stage would start processing the record. If this would have been the case, then the whole time taken for the DataStage job processing would be huge. But in this case, what happens is that as soon as the first stage has processed, let's say 10 records and output those 10 records, then the next stage would pick up those 10 records, process those records, and output it for the next stage. So this is your pipeline parallelism. Now other parallelism which we are quite aware of is the partitioning. So partitioning is basically splitting the data into multiple streams. So you have 100 records, and let's say you define your 4 partitions in your job. So you have 25 records for each partitions based on the kind of partitioning that we define. So if they're equally distributed and there are 25 records for each partition, all of those partitions process the data at the same time, then obviously you need only 1/4 of the time for your DataStage job to complete processing, instead of if all the 100 records would have been processed only in a single stream of data, only by a single partition, it would have taken 4 times the time, the whole processing time. So this is your pipeline, this is your partitioning parallelism. So the two kinds of parallelism in DataStage, pipeline and partitioning. Now another question which is related to the partitioning techniques, which are very important again in DataStage. For many of your stages to work correctly, you need to define the correct partitioning technique. So for that, you first need to be aware of the different kinds of partitioning techniques in DataStage. So there is the round robin, hash, entire, same, random, and modulus. So you should be able to list all those partitioning techniques. Now random and modulus are almost never used, so do not worry about the details of them, but you should be aware that these two kind of partitioning techniques also exist. The important ones are obviously round robin, hash, entire, and same, and you should be able to explain what these partitioning techniques mean as well. Now an indirect way of asking the question, instead of simply asking what this partitioning technique does, they might simply ask you which partitioning technique results in equal distribution of data. So equal distribution of data is your round robin partitioning. And round robin partitioning, the way it works is that it sends the first record to the first node of partition, the second record to the second partition, third record to the third partition, fourth to the fourth partition, fifth record again to the first partition, sixth record to the second partition, and so on. So it works in this cyclic order, and it sends one record at a time to each node. That's why it results in almost an equal distribution of data. So this is your partitioning technique, which would result in an equal distribution of data. Now, what is the use of this partitioning technique? Why would we want the data to be equally distributed? Again, for the optimum performance of the job, so that the job takes an optimum amount of time to process. So equally distributed data, if there are 4 partitions, they have equal amount of data, they'll be taking almost the same time to process the data, and your overall processing time would be reduced. Whereas if the data is unequally distributed, so one partition has to process, let's say, 50 records, the second partition has to process only 10 records. Now the second partition processes those 10 records in a shorter duration of time, whereas the other partition is still processing those 50 records it needs to process. So the overall time for the whole job to finish processing would increase. So that is the scenario where you would go for round robin partitioning, when there is no explicit need of any key based partitioning, and you want an optimal performance for your DataStage job. Then you have to make sure that the data is equally distributed across the partitions, and you can define round robin partitioning. Now, what is the use of same partitioning? So this is a direct question. What is the use of same partitioning? Now, same partitioning is used when you need to retain the partitioning that you have defined for a previous stage in your subsequent stage. So let's say you have a sort stage and you have partitioned and sorted your data based on let's say employee ID and department ID, and you generated some key change column and so on. Now after the sort stage, you're using the transformer stage and you're doing some calculations where you again need the data to be sorted on the employee ID and the department ID. So in this case, what you would do is, in the sort stage you would go and define the partitioning as hash, and hash partition and sort data on the employee ID and department ID key columns. Now when you go to the transformer stage, the data has already been sorted and partitioned on employee ID and department ID. So here you can just define same partitioning instead of defining the hash partitioning once again, and again partitioning the data on employee ID and department ID. So this would also increase the performance of your job, because DataStage in the backend would not be needing to partition the data once again. It would just read that the data has already been partitioned because you have defined same partitioning. And the way same partitioning would work is basically it would just copy the data from the node, from the instance of the sort stage on node 1 to the instance of the transformer stage on node 1. So it would just simply copy the data, as you can see in this figure. So just copying the data from the previous stage to the next stage, node by node. So this is your same partitioning. Now an important area where we need to explicitly define the partitioning and define it correctly are the join and lookup stages. Now the other, like we discussed, the same partitioning. So even if you do not define same partitioning and you define a hash partitioning once again, your the output data would be correct. So it would not define the output of your data, all the results of your computations, if you do not define same partitioning. That same partitioning you need to define to improve the performance of your job. Similarly with round robin, if you do not define round robin partitioning, the output data would not be affected. The results would not be incorrect. It would only affect the performance of your DataStage job. But if you do not define the partitioning correctly in join stage or lookup stage, or where you need to perform any key-based operation, then your data results would be incorrect, and that would impact all the job. So you need to be very careful while defining the partitioning for the join stage and the lookup stage. So which partitioning would you use in a join stage? Straight away you have to use hash partitioning. There is no other alternative. You have to use hash partitioning, because the way a join stage works is by combining data on key columns. So it tries to find match between the primary and secondary links based on the key columns. So you have to make sure that all the records with the same key column values end up being in the same partition. from both the lengths, because if they do not end up being in the same partition, if you have a key column value of 1 and you have 10 records with that value, you have 5 records in one partition, you have 5 records in another partition, then when your join instance operation takes place on partition 1, where you have only got 5 records and the other 5 records are lying in some other partition, it will not be able to match with the with those records lying in the other partitions, and your output results would be incorrect. So you have to use hash partitioning to make sure that all the records with the same key column values end up being in the same partition. Now, which partitioning would you use in a lookup stage? The lookup stage has a similar function as a join stage. It tries to find the matches in your reference data set. Now, there's a special kind of partitioning that's used for the lookup stage, and that partitioning is only used for the lookup stage. It is not useful anywhere else, and that is your entire partitioning. Now, entire partitioning basically will copy all your data, all your reference data across all the nodes. So when you have a primary input record that comes in and you try to find a match, you have that data in all your partitions and it is held up in memory. So this match will happen very fast, because this is an in-memory operation that happens. All the nodes have all the reference data, so it doesn't need to go across partitions to find a match. So that is where you need to use an entire partitioning. Now, the answer to this question, what is the difference between a join and a lookup stage, would make the previous answer more clear. So as a DataStage developer, again, you have to be careful and you should be aware of where you should use a join stage and where you should use a lookup stage, because as we have already mentioned, the functionality is more or less similar. You can achieve the same outputs using any of these stages, but your performance would severely differ from one stage to another stage. So you have to know which stage to use in which scenario. Now, a lookup stage is used when your reference data set is small and is small enough to fit in your RAM or memory. Okay, so if you are doing, let's say, a lookup, you have some country codes coming in and you are doing a lookup with a country. There's a country reference table or a lookup table, and you are fetching the country details using that table. So there are only a finite number of countries in this world, and they're not going to be millions of records in that reference table. So it is small enough to fit into your memory. So this is where a lookup stage would perform very well. But if you're doing a join on two different data sets which have like millions of records in each of the data sets, so your primary input link also has millions of records and your secondary input link also has millions of records, in that case, if you use a lookup stage, then all this data will not fit into RAM. So basically your performance of your DataStage job would be severely impacted, because the data would not fit into RAM. It would actually just hang. Your DataStage job will just hang. The system would crash. So in this case, you have to use a join stage. Now, how does join stage work with this large volume of data? There is a necessity in join stage to sort and partition the data. Partitioning is for the correctness of the output results. You sort the data to make this matching operation faster. So you have to, it improves the performance with larger volumes of data by sorting the data. So simple rule of thumb, if your reference data set is small enough to fit into your RAM, again your RAM differs from project to project, so it depends on your resources of the project. So if your reference data set is small enough to fit into your RAM, you should always go for lookup, because again it would use your entire partitioning as we discussed earlier to find the match. And because all the reference data set is held up in the memory, the operation would be very fast. Whereas if you have larger amount of data, then a lookup would never work in that case, and you have to go for join stage. You have to make sure that the input data is sorted and partitioned correctly, so that your results are correct and the job performance is also efficient. Now again, more detail, because join is one of the very important stages in DataStage, because DataStage is basically a data integration tool. So you are mostly reading data from multiple sources, and you are combining data, you are looking up data, and so on. So join stage is used almost all the time in a data stage job. So how does a join stage work? If you have a primary link and you have a secondary link, and you have data coming in from the primary link, and you are finding the matches in the secondary link, but what about those records which do not find the match in the secondary link? How can you collect those records? So how can you collect non-matching data from a join stage? So basically a join stage, through a join stage, you can implement different kinds of joins: the inner join, the left outer join, the right outer join, and the full outer join. So these are similar to the SQL joins. The inner join is basically matching data from both the links, primary and secondary links. Left outer join is all the data from the left link matching data from the right secondary link. Right outer join is all the data from the right primary link matching data from the left secondary link. And full outer join is data from both the links and where the data is not matching. So any data from the left link not matching in the secondary link will have nulls in the output records or the output values from the secondary link, and vice versa. So all these different kind of joins can be implemented through a join stage. The basic functionality that you need to remember and understand in this case is that whenever there is non-matching data, so you have a record coming in from your primary link and you do not find a match in the secondary link, then the join stage would output null values for all the attributes coming in from the secondary link if it is a non-matching record. So the values for attributes for non-matching records are populated as nulls. This is your key functionality that you need to remember in this case. So how can you collect non-matching records? Just by collecting any attribute with the null value in it. Now there is a catch here, and you have to be careful. You have to make sure that, because a null can be a valid value as well, so you have to make sure that whatever value or attribute you're collecting from the secondary link to catch the non-matching records is not a nullable column. It is a non-nullable column, or you're sure that it always has a value. Null should not be a valid value in that attribute from the secondary link. Okay, so be careful about that. Now this is one of the scenario based question. Okay, so we'll be covering more scenario based questions, so I'll make an entire video with only scenario based question, but this is how the questions would be asked. So this is simply an employee is assigned to 2 projects. The lookup stage is used to fetch the project details, but it is finding only one project match and dropping the other. How can you fix this? So this is basically an employee, let's say an employee Tom, he is assigned to 2 projects, and one is project A, another project is called project B. So now we are using the lookup stage, and we are looking up on the department or the project ID or the employee. We are looking up on the employee ID, and then this reference table has employee ID and project ID. So employee ID 1, let's say Tom has an employee ID of 1, and in your reference table you have 2 records now for employee ID 1. And one of the records has the value project A, one of the records has the value project B. But when you are going to use the lookup stage, you are going to get only, let's say, project A in the output. So project B is not coming. So what could be the cause? Now this is a common scenario and lookup stage, and if you look at the director log and you have used the lookup stage, you would and many times find the warning that there were duplicate records and the reference link in the lookup stage. So you would find that kind of warning. Now it depends on your requirements and your data. A duplicate could be a valid data, it could be an invalid data. So if it is an invalid data and you get that warning in your director log, then straight away it's a data issue. You need to report it to the business owner and they need to fix the data. If it is valid data, like in our scenario, because an employee can be assigned to multiple projects, so this is a valid scenario and we want all those 2 project details to be fetched. So for those scenarios, you have an option in your lookup stage properties, and that is called multiple rows returned from link. So in this case, as you can see in this figure, and you can just select the link name, your reference link name in this option, multiple rows returned from link, and then you would be able to get both the project details in your output. Okay, so how can you implement left outer join in a lookup stage? So lookup stage, many times we have an understanding that a lookup stage would only be used to find a match in the reference data set, so it works only as an inner join, but you can use it as a left outer join as well. And the setting that you need to change for this is basically your lookup failure option. Again, in the properties you can see that there's an option over here. It is set to reject. If it is set to reject, then basically any non-matching record would go down the reject link of the lookup stage. But if you set this to continue, then what will happen is that all the non-matching records would also go to the output. So in this case, it would work as a left outer join. So this is how it would work as a left outer join. Now, what is the difference between normal and sparse lookup? Now, again, many of us, we just go by the default of normal. We're not even aware of that there's a sparse lookup because it is rarely used, but there are scenarios in which a sparse lookup could be useful. And you can see on this slide, there's a lot of detail on this slide, but the important thing that we need to note here is that a normal lookup is in the scenario where you have a reference data set which can fit into memory. You go for a normal lookup. But what if your primary data set is small and your reference data set is big in comparison to each other? So let's say your primary data set has 10 records, whereas your reference data set has 1000 records or 10,000 records. Now these 10,000 records, because it's a small table, so the volume is not that high and it can fit into your RAM. So you can go for a normal lookup. But if you go for a normal lookup, you have just 10 records in a primary link. So what is faster in this scenario is to go for sparse lookup. Now sparse lookup can only be done with data sets. So your reference data set should be actually a database. Sorry, it can only be done with a database. So your reference data set, which we are talking about, should actually be a reference table in a database. So what it does is basically it will fire an individual SQL for each of the 10 records in your input link. So 10 records in the input link, 10 individual SQLs fire to the database to find a match, and anything that is done in database is always faster than being done in DataStage because there's less input output involved here, IO operations involved here. So any operation done in database is always faster than done in DataStage. So that is why a sparse lookup would be faster and more useful in this scenario, because individually you have 10 records, 10 individual SQLs would be fired. You have 15 records, 15 individual SQL statements would be fired to find a match in your reference database table. So in this scenario, you can go for a sparse lookup. So if you are asked this question, the answer that the interviewer would be expecting is that you have to explain that a sparse lookup is used when your primary data set is small, but your reference data set is much bigger than your primary data set. Generally, you can, in general terms, you can say, and it is said that it should be 1:100. 1:100 should be your ratio, as you can see here. Okay, 1:100 should be your ratio. Okay, so next question again, what is a configuration file? So configuration file, basically this question is for all levels of software programmers. So even if you are a junior level programmer, do not assume that you will not be asked this question, because this is more like an admin thing or something, something that administrators do, something that senior level programmers do. You should be aware of what is a configuration file, because again it relates to the basic principle of DataStage, which is its parallelism. So a configuration file basically defines the number of nodes. Nodes are nothing but partitions which are there for your DataStage job. to run on, to execute on. So you can define your degree of parallelism in your configuration file by defining the number of nodes to be used. Now you can define many more details in the configuration file for your nodes, your hardware details, your resource details, your scratch disk details, your pools, and so on. This is for the advanced level, so we'll skip it for this video. If you want more details on the configuration files, I'll paste the link below in the description box for the configuration file, and you can just go and watch that video tutorial that we have, and it has all the details about the configuration files. But as a general question as to all levels of programmers, what is a configuration file? A configuration file is basically a file where a system file where you can define the number of nodes, and those nodes are basically partitions that your DataStage job runs on. So it is a way to define the degree of parallelism for your DataStage job. Now a DataStage job can use a configuration file. A DataStage project can have multiple configuration files. So you can define one DataStage job to use one configuration file. You can define another DataStage job to use another configuration file. So it is not limited to one configuration file. Configuration file is nothing but apt.config file. That is how it is defined. I have not mentioned it here, but this you should know. So I'll be pasting the link below, and you can go to that link and you can get more information about the configuration file. But on a basic level, you should always know that what is a configuration file and what is the use of a configuration file. Okay, so now the next important feature of DataStage, so we'll be covering stages by stages. So file systems. So again, this is kind of a scenario based question that your ETL process generates an output file for the downstream system. Should it be a dataset or a sequential file? So these are the two most important file systems, and these are the ones that I use, sequential file or a dataset. So to answer any of the questions related to these, you have to be aware of what is a sequential file, what is a dataset, in what scenarios to use a sequential file, and in what scenarios to use a dataset. So sequential file is basically a file that is accessible by external systems. So it's a flat file, and you can access it through Unix, you can access it through Windows or any of the external systems. It is any file with an extension of .text, .dat, your Excel files, your CSV files, all those files can be read by sequential file stage. Okay, so that is a sequential file. So the important thing to remember here is that it's a platform independent file. So if you need to generate an output file that needs to be accessible by external systems, then it has to be in the form of a sequential file. Or if you're reading data that is coming from some upstream system or some other external system in form of files, then you would be getting that data in terms of sequential files and reading it through your sequential file stage. Whereas a dataset is something for the intermediate storage of data in DataStage, because it is in the native DataStage format. It is partitioned, and therefore it is platform dependent, so it can only be read by DataStage. So if you're an external system, you pass on a dataset to an external system, it cannot do anything with it. It's garbage to that system. So a dataset is to be used internally by DataStage. And then why can't you use a sequential file internally by DataStage or for intermediate storage of data? Because the dataset has an advantage of being partitioned and being in a native DataStage format, so it is faster to process than a sequential file. Okay, so that is the advantage of using a dataset for intermediate storage of data. So next question is again related to the same concept. Your transform process generates an intermediate file to be used for loading data into the target data warehouse table. Should it be a dataset or a sequential file? So I have the keyword here, which is intermediate. Intermediate means dataset. So the whole scenario here is, let's say you have an ETL, you are designing an ETL job. So you have split it into three modules: your extract job, your transform job, and load job. So you extract from a database table and you can put that data into a dataset. Your transform job can read from that dataset and manipulate the data and then generate another dataset which can be used by the load job to load it into the final data warehouse table. So this is where a dataset would be useful. Okay. Now, how can you delete a data set? Now, this is another very important question. And if you have not done this, then you might think that it is similar to the way we delete the sequential files. So you can just go, if you're using a Unix based platform, then you just go to the Unix server and put an rm-f command and delete the dataset. But this is not true in case of dataset, so we have to be very careful to be deleting whenever we are deleting the dataset, which we would be doing from time to time, because otherwise all the deleted datasets and all those things, they consume a lot of space. So you would be cleaning your system at some point of time. So how do you do that? You have special ways to delete datasets. You have a utility called the dataset management utility. So you can delete the dataset using the dataset management utility. If you want more details on that utility, I will put the link below in the description box for a video tutorial on dataset management utility. The other way to do that is use the org-admin command of DataStage, and the way you write that command is org-admin delete and then your dataset name. Okay, so demo.ds, because ds is your extension for the dataset. So you write org-admin delete and then your dataset name. So these are the two ways in which you can delete the data set. Now, what if you use rm-f and delete a dataset? What would happen? So you might think that it has got deleted. It might disappear from your directory or folder structure, but it would not be deleted completely from the backend, because a data set has a different way of storing in your operating system. So it is a set of descriptor file and data file. So when you just write an rm-f, it just deletes the descriptor file. Your data file still remains. So data files are the ones which have the actual data. A descriptor file is basically like a metadata file. So you have the creation timestamp, you have the structure of the data that is stored, the pointers to the locations of the data file, and so on. So again, this might be another question, and you need to understand how a data set is structured. It is a set of two files, descriptor file and data file, and that is why we cannot use a simple rm-f command on a data set. Instead, we have to go for the dataset management utility or the org-admin delete command. Now, how can you make the sequential file stage run in parallel? So sequential file, by name, it looks like it should run only sequentially. Sequentially means that it would run only in a single node or a partition, so it would not run in parallel. But this is not true. A sequential file stage can run in parallel while reading a single file. So there are two options. If you go to the sequential file, you will see that there are various options, and two of those options are read from multiple nodes and number of readers per node. So read from multiple nodes is basically for a multi-node system. So you have multiple nodes, you can set this to yes. If you set this to yes, then the same file, the data in the file would be split into different instances on the node, and it would be read simultaneously. So it would be kind of partitioning happening and parallel read happening. So parallelism. The other option is number of readers per node. So when you can define for each node, you can define multiple instances of the read operation that takes place. So again, the data is split into chunks for those multiple instances, and the data is read in parallel. So this is how you can introduce parallelism in sequential files. Now, thing to remember that these are for different kind of systems, and therefore these are mutually exclusive properties in a sequential file stage, which basically means if you would go to the sequential file stage and try to set either of these properties. So let's say you set read from multiple nodes as yes, the number of readers per node property would disappear. So you cannot set it there. So you can set only one property at a time based on your system. Now, how can you define dynamic column definitions in a sequential file? So when we define a sequential file, what we basically do is we define the column names, their data types, their lengths, and so on, the labelity, and so on. That is how we define. So employee ID, employee name, first name, last name, and so on. So that is how we define. But what if we do not know the column structure? So that happens in some projects wherein you get a separate schema file. That schema file has your metadata information or the column definition and table structure and column data types and so on. So in those scenarios, there is an option called the runtime column propagation or the RCP option. So if you do not define the columns, if you do not hard code the column names and the details on the sequential file columns tab, then you can read it from the schema file, and you can just select this option, runtime column propagation, and any extra columns you just read from the schema files and propagate them to the job. Or if you just click on it, if you have selected the RCP option and in your let's say copy stage you had 5 input columns, but you only mapped only 2 output columns, and you selected this option of RCP, then it would automatically read the other 3 columns as well. Okay, so this is how RCP works. Now this RCP option, it can be set in the DataStage administrator client for the whole project level, so it would be checked by default. You can uncheck, you have to remember to uncheck it, otherwise you will get warnings again. And it can also be set at a stage level on the output tab of the stage. So this is how you can use schema files and you can have dynamic column definitions in a sequential file. So these were some of the questions for today and their answers. Please let me know in the comments if you found these helpful, and you can also let me know other questions that you have been asked probably in some interviews and you would want answers to. You can also like and share this video if you like it, and again, please do not forget to subscribe to our YouTube channel because we'll be posting more videos, and this was only the first video in the series. I'll be posting more videos and more scenario based questions, so there will be more videos coming out. So stay tuned and thank you for watching this video.